Welcome to my YouTube channel Healthcare Knowledge. Today I am going to start a new chapter called Oscillations from Class 11 NCERT for Neet 2024 batch. So our class is purely based on NCERT and we will be going through NCERT readings also in between the classes. So let's start our today's class. So subtopics in oscillations according to NCERT, there will be 10 subtopics, 10 objectives of the lesson oscillations. That includes introduction, periodic and oscillatory motions, simple harmonic motion and uniform circular motion, velocity and acceleration in simple harmonic motion, force law for simple harmonic motion, energy in SHM, and last some systems executing simple harmonic motion, last damped simple harmonic motion, forced oscillations and resonance. So one by one we will be discussing each subtopic. We will be covering each objective of the lesson. So let's start with introduction. Let us see the definition of oscillatory motion. What is oscillatory motion? Study of periodic fro and to motion about its mean position. So what is oscillatory motion? Study of periodic. Periodic means the repeative motion. For example, orbitary motion of a planet is an example of periodic motion. Fro and to motion means, for example, if we take a pendulum, let me explain you. For example, this is an wall clock. A simple pendulum is hanging. So here let us see the mean position be O. So this is bob. This is called bob. This is called BOB, bob, a metal ball. It oscillates from its mean position O. Then the bob will go front and back, to and fro. So this type of movement or this type of motion is called oscillatory motion. Okay, oscillatory motion. So the whole chapter is being discussed about oscillatory motion. So let me explain you some examples of oscillatory motion. Swinging on a swing. It is an example of oscillatory motion. For example, this is an swing. This is an swing. I don't know how to draw, so I draw it roughly. So it goes back and front, front and back. So this to and fro motion about its mean position. So here, when the body is kept at rest, it is left at rest, it is said to be equilibrium position or mean position. So pendulum of wall clock is second example. We already discussed about pendulum of wall clock. And next, musical instruments. So examples. What are examples of musical instruments? Let me take another color. Yeah. Musical instruments such as guitar. The string is being oscillated. For example, when we take a guitar in fretboard, there will be strings. When we play, the string will oscillate up and down. To and fro motion it exhibits to and fro motion. And next, atoms vibrating in solid. So in solid, for example, when we take a solid, the atoms are not stable. We can say that we think that solid is at rest, but the atoms present in solid always moves to get stability. So they exhibit which motion? Oscillatory motion. Oscillatory motion. Then AC power. AC power is the alternating current which we use in our daily use. In our home we use so many house appliances. So for that we required alternating current. So when we see the waves alternating current waves flow like this. So here the movement or the motion exhibited is called oscillatory motion. Let's move on to next slide. So in introduction, according to NCERT, we require 5 fundamental concepts to understand oscillations. First one is period, second one is frequency, third one is displacement, fourth one is amplitude, fifth one is phase. So here total 5 fundamental concepts are required to know about oscillations. I will be explaining about these 5 fundamental concepts in next slides. So before going into these fundamental concepts, let me explain you what is wave. So wave is a disturbance in a medium that carries energy without a net movement of particles. So here disturbance in a medium, for example, if you take a medium, for example, when we take a beaker of water, we have water in it. Let me fill it with water. So this is water. Now when we hit that container or beaker with tuning force, when we hit the beaker with tuning force, then there will be disturbance. Okay, then there will be disturbance in that beaker. Okay, there will be some disturbance. So the disturbance that carries energy without a net movement of particles. So here net movement and net movement is 0. Okay, net movement is 0, but the particles are being moved without a net movement and it carries energy. So this is called wave. So here you can see these ups and downs. When the wave goes up, it is called a crest. What we do call it? Crest. And lower one, when it goes below the mean position, let me say this is X and H is let's denote with let me denote with O. O is mean position. So here positive, here negative, let's take. I will be explaining about waves in further videos. So here let me explain you just in simple way. So when wave goes up and it comes down and up and down. Okay, now this is called crest and below one is called trough. What we call trough. So wave is composed of number of crests and number of troughs. Okay, and here this line indicates, this dotted line indicates mean position. It indicates mean position. So let's move on to next slide. Now let me explain you the fundamental concepts required to understand oscillations. So interval, let me explain you about period. So what is period? Interval of your time for a motion to get repeated. So for example, here from mean position the graph is coming like this and goes up and comes down. So this you may see this position is repeated once again. Okay, I mean this part, let me explain you, this part is repeated here once again. Here once again it is repeated. So the time difference between this repetition, okay, this is a motion, this is also a motion. To exhibit the same motion, the time required to repeat that motion is termed as period. Okay, that time taken to repeat that motion is called a period. So let's move on to next slide. Next one is frequency. So what is frequency? Number of waves that pass by each second. Number of waves that pass by each second. For example, for 1 second, how many waves are passing? That is called frequency. Frequency is denoted with a Greek letter nu. It is denoted with Greek letter nu. Okay, we will be discussing frequency more in next slides. So number of waves that pass by each second is called frequency. For example, one crest, one trough constitute one wave. One wave. So how many number of crests and troughs, how many number of waves are being passed, per 1 second. For 1 second, how many deflections are being seen in this graph? How many deflections are being seen here? How many waves are being passed? For example, let me take, this is a time period of 1 second. 1 second. Here you can see that here one wave, 2, 3. When we consider one crest and one trough as one wave, then 3 waves are being passed per 1 second. So frequency will be 3. Okay, let's move on to next slide. Next one is displacement. So what is displacement? Relative change in a position of a wave as it travels through a medium. So we already discussed that here the particles carries energy without net movement. So here a medium is necessary for this traveling, for this kind of disturbance. Okay, so here then the wave will change its position. Then when particle changes positions, particle is at rest here, but it changes position because some disturbance is being happened inside it, so it will show some waves, it will show some displacement. When waves are formed, automatically displacement is also formed. Am I right? Relative change in position of a wave as it is traveled through a medium. So here it is traveling through a medium, so it gets displaced. So here you may see 0 is the mean position, and here the particle is being disturbed, so it shows some movement and waves are produced here. So this wave indicates the displacement. Here you may see that on y-axis displacement is denoted. Okay, displacement is denoted. The object is disturbed and it gets excited, it gets displaced more, then the displacement is positive. Okay, this is displacement. These fundamental concepts will repeat in every topic of the chapter. Students, please remember, these fundamental concepts should be clear to you thoroughly. Okay, thoroughly study all these fundamental concepts, because these will be repeating in waves concept and as well as in alternating current and all the other concepts of modern physics. Okay, so let us see amplitude. The maximum displacement or distance moved by a point on a vibrating body or wave measured from its equilibrium position. So what is equilibrium position? Let me explain you equilibrium position. Here we know this is mean position. When the object, let me consider an object of mass m, it is at mean position O. Okay, it is at mean position O. Someone came and touched that object, means they created some disturbance in that object. The atoms gets disturbed and gets vibrated. So here what will be happening means it gets disturbed and it gets excited and displaces. So here, before disturbing that object, what is the state of that object or the body? The state is, it is at rest. Okay, it is at rest. So if it is at rest, automatically here we can see there is a base or there is a line, surface is at rest. Then automatically when the object is also at rest, then both are in equilibrium. So the mean position of an object can be said to be its equilibrium position. Okay, now when an object displaces, from its mean position, it gets displaced. So here the maximum displacement, is called amplitude. Okay, the maximum displacement is called its amplitude. Okay, amplitude. I will be sharing these all notes as PDF. You can download all these notes from the description box using the link given, and after this video you can attempt and test, which is totally free. I will be giving the link in the description. Just open that link and attempt the test, and automatically the score will be generated after the test. Okay, the test is completely based on this video class only. You can find answers to the test in this video. Okay, and notes will be provided. These notes will be provided in description section, so don't worry about notes. Just concentrate on the class and concentrate on what I am saying. Okay, let's move on to phase. So what is phase? State of particles with respect to its position and direction of motion in path of its vibration. So state of particles. So let me consider some waves. Okay, this is one wave. Let me indicate this wave with W1. This is wave 1, and another wave is there. This is wave 2. Okay, this is wave 2. Here when we consider two waves, so to compare these two waves we use the term wave phase. Okay, to compare these two waves W1 comma W2 we use the term phase. Means we are seeing with respect to its position, so where it is located with respect to its position and direction. It is going up, it is coming down, it is traveling up, it is traveling down. So based on this position and based on the direction of motion in path of its vibration, means here vibration is taking place now, so we say that motion is in the path of its vibration. To compare two waves we use the term phase. Okay, so later we will be discussing about phase difference also. So these are 5 fundamental concepts. Let's move on to next slide. So introduction. I already explained, I already told you that we will be reading NCERT thoroughly along with the class. Okay, so here see, in our daily life we come across various kinds of motions. You have already learned about some of them. Example, rectilinear motion and motion of a projectile. So motion of a projectile we have discussed in motion in a plane as well as in motion in straight line. So what is rectilinear motion? Rectilinear means linear motion. It is rectilinear linear motion. So here both these motions are non-repetitive. So the points which I am highlighting here, please try to highlight in your NCERT also. Okay, just wait, I am changing my highlighter color. So see, we have also learnt about uniform circular motion and orbital motion of planets in solar system. In these cases the motion is repeated after a certain interval of time. Means Earth is rotating itself. Okay, for example, how to explain? I'm thinking about example. Yeah, I found it. So this is Earth. Okay, Earth is rotating itself, and again it comes to its mean position when time is 5:30 in India. The Earth is at its some special position. I mean it is present at its mean position. Okay, so again next day at 5:30 it will come to that position. It will take one rotation. And it attains its mean position. So this motion is said to be non-repetitive motion. Okay, so it is said to be periodic. So the term periodic is very important, and the examples are also important. Orbital motion of planets in solar system is example of periodic motion. In your childhood you must have enjoyed rocking in a cradle or swinging on a swing. I have already explained to you. Both these motions are repetitive in nature but different from the periodic motion of a planet. Here the object moves to and fro about a mean position. So in periodic motion or in oscillation, in oscillation, so here periodic motion and oscillation are different. Okay, so here the object moves to and fro. I already told you a definition of oscillatory motion. The pendulum of a wall clock executes a similar motion. Examples of such periodic to and fro motion abound. A boat tossing up and down in a river, means boat going up and down. The piston in a steam engine. In a steam engine, the piston goes up and down and up, to and fro. And such a motion is termed as oscillatory motion. So what do we call this motion? We call it as oscillatory motion. So in this chapter we will be studying this motion. The study of oscillatory motion is basic to physics. Its concepts are required for the understanding of many physical phenomena. In musical instruments, highlight this point, like the sitar, guitar or the violin, which are throws vibrating strings that produce pleasing sounds. The membranes in drums, in drums there will be a membrane, the upper surface of the drum or pads, drum, not pads, in drums, diaphragm there will be a thick coating, so it vibrates to produce sound. Okay, it vibrates to produce sound. It is an example of this motion. In telephone and speaker systems, to and fro about their main position, the vibration of air molecules make propagation of sound possible. Okay, so air molecules vibrate so that they carry energy. What is that energy? Sound energy. Okay, sound energy is carried by some particles. What are those particles? Air particles. So those air particles by traveling they carry sound energy and transmits that sound energy along with air molecules. So for this, which motion is required? Oscillatory motions. For example, I am communicating with my friend. Okay, to communicate I release some sound energy from me. How the sound energy is being transferred to my friend? So it requires a medium. So when the medium is present, it requires a mediator also. Medium is like mediator, but still some particles are required now to capture this sound energy and to transmit my sound energy to my friend. So the here air molecules are being considered. So also for board exams, this propagation of waves also will be useful during the chapter waves. So I will be explaining you the propagation of sounds. Propagation of sound in waves more deeply. Okay, so let's move on. In solids, the atoms vibrate out their vibrate to move out their equilibrium positions. The average energy of vibrations is being proportional to temperature. Okay, note this point. Average energy of vibrations. I want to write with pen. Okay, just 1 minute. Yeah, average energy of vibrations. Average energy of vibrations is directly proportional to temperature. So when temperature increases, vibration average energy also increases. The kinetic energy of vibration also increases. Okay. So let's move on to next one. AC power supply gives voltage that oscillate alternately, going positive and negative about its mean value. So highlight this point, children. So highlight this point, students. Very important point. In alternating current, it goes ups and downs. It shows. Positive displacement as well as negative displacement. Okay. So next, here we can see that mean position is denoted with O. So what is this? This is called it shows oscillations. It is an example of oscillatory motion. Okay, let's move on to next one. Okay, let's move on. Yeah, so let me explain you periodic and oscillatory motions. Periodic and oscillatory motions, according to NCERT, I am going through objectives. The main objectives. I am following main objectives. So 14.2, periodic and oscillatory motions. So it includes of two subtopics. I already told, you may get doubt that you already told subtopics or 10 topics, then why again subtopics? I am saying that this is an objective. Okay, this is an objective topic, periodic and oscillatory motion. Again, it is being divided into two subtopics to understand in better manner. Okay, so what are those two subtopics? Period and frequency. 14.2.1 and 14.2.2 displacement. So before going into period and frequency and subtopic displacement, I will be explaining you about the periodic and oscillatory motion differences. Okay, to know difference, you should know the applications. The examples of periodic motion as well as oscillatory motion. I have already given the examples for periodic motion, such as planetary motion. Orbitary motion of planets is an example of periodic motion, as well as simple pendulum. Motion of a simple pendulum of a wall clock is an example of oscillatory motion. Okay. So periodic and oscillatory motions. So what is periodic motion? A motion that repeats itself at regular intervals is called periodic motion. I already told you. So to repeat an interval, okay, to repeat a motion, it requires some time, okay, it requires some time, okay. Okay, here to repeat a motion, let me draw and explain you. Yeah, let me draw and explain you. So let us see. So let me consider a mean position. Okay, this is a wave. It is going ups and downs. I mean, it is doing positive displacement as well as negative displacement. Okay, let me say the mean position of this. I mean, mean position be O. Okay, sorry for joining this mean position. Sorry. Yeah. Okay. Yeah. Let me denote with O. Okay, it is coming waves. Positive displacement, negative displacement. Okay, here this is a motion. Okay, this is a motion. Let me say this motion be as m1, okay, and this is m2, okay. Here m1 is equal to m2, that is motion 1 is same as motion 2. So so to repeat these motions, how much time is required? I mean, how much time is required? That is called periodic motion. Okay, that regular interval. Okay, at regular intervals the motion is being repeated, and that time of interval is called periodic motion. I mean, that interval, that motion is called periodic motion. So that interval is called time period. Okay, that interval is called time period. So periodic and oscillatory motion examples, let us see. Okay, here example for periodic motion, first one is crawling insert. For example, consider an insert. Okay, let me just write. Yeah, it will be done with black color, and let me change pointer size. Yeah, okay, it will be. So let me consider one insert. Okay, this is an insert. Okay, insert is crawling up. I mean, this is surface of earth. It is crawling up, and again it suddenly falls down. Crawling up and suddenly fell down. Crawling up, fell down. Crawling up, fell down. So here this is an example of periodic motion. So the motion, see here, the motion is being repeated at regular intervals. Okay, so the graph A which of NCERT indicates about this crawling insect, climbing child. So let me consider another example. This is this is earth surface. Child is climbing one step up, staying at that time for some time and coming down, and waiting for some time on the ground, and stepping up and waiting for some time, few minutes or few seconds, and getting down. So here the motion is being repeated at regular intervals. Okay, regular intervals. So HT graph, here the graph is time. Okay, time and display. I mean, HT graph, it is denoting H is time, H is displacement, and the T in bracket represents the displacement is being changing with respect to time. Okay, note this point. Displacement is being changed with respect to time. Okay, so that we can easily study these graphs. And next graph, a bouncing ball. Okay, you throw it and ball. Okay, so let me clear all these things, and let me explain you that ball, bouncing ball example. So you took an stumper ball. Okay, you took an stumper ball. You thrown it down, it touches the ground, and it bounces with how much force you applied according to Newton's law of motion. Every action has equal and opposite reaction. You applied, okay, 10 newtons of force. Again it reflects back with 10 newtons or less, because when it touches sound, it releases its some energy or sound in the form of sound energy. Okay, force is being converted into sound energy. Sometimes it may not be 10, so this is not required. Just I am explaining about periodic motion. Again you touches the ball, I mean you bounces it to the ground. Okay, you bounces it to the ground. Again it touches ground and bounces up and down. So here you may observe. Okay, let me highlight this with red color. So red color, why it is not being selected? Yeah, see here the motion is being repeated at regular intervals. So here displacement versus time graph C indicates about this bouncing ball. Okay, let's move forward. So let us study NCERT. Periodic and oscillatory motion shows some periodic motion. Suppose an insect, we already discussed about that insect example, climb up a ramp and fall down, it comes back to the initial point and repeats the process identically. If you draw a graph of its height above the ground versus time, it would look something like figure 14.1. I told you that it is about graph. Graph 1 is about that that insect climbing example, okay. Graph 2 is about graph 2 is about child example, and graph 3 is about bouncing example, okay. So when you play the game of bouncing of a ball off the ground between your palm and I forgot to tell you child example now. So if a child climbs up a step and comes down and repeats the process identically, its height above the ground would look like that in 14.1b. So here you can see the graph B. When you play the game of bouncing ball off the ground between your palm and ground, means you're taking your palm, bouncing the ball to ground to your palm and palm to your ground. So its height versus time graph would look like the one in figure 14.1c. Note that both the curved parts in figure 14.1c are sections of parabola given by the Newton's equation of motion. So Newton's equation of motion, when the ball is moving down, here you can say h is equal to, height is equal to ut initial velocity into time plus half gt square, okay, ut plus half gt square. I will be explaining that equation in further videos, but it will not be required for the test which is given in the description. So I will be explaining in next video, and in the next test you will be answering questions about these formulas by applying these formulas. H is equal to ut plus half gt square. Here g is positive, okay, because gravitational constant, gravity is constant, is positive because it is positively geographic. Means ball is coming downwards. Downwards means it is coming down, so it will be positively geographic. So gravity is being ball is being attracted by gravity, okay. It is coming towards gravity, so it will be positive. And h is equal to ut minus half gt square, minus half gt square in upward motion, because ball is coming to is being directed towards your hand, means it is away from the ground, means away from the gravity, so it will be negatively geographic, okay. So here with different values of u in each case, these are examples of periodic motion. So these are examples of periodic motion. There's a motion that repeats itself at regular intervals of time is called periodic motion. So what to be highlighted, I'll be highlighting. So just highlight it. A motion that repeats itself at regular intervals of time is called periodic motion, okay. Let's move on next slide. Yeah. Okay, let's move. Yeah, periodic and oscillatory motion, relation between oscillation and periodic motion. So the statement which is highlighted is very most important, guys. It will be useful in next concepts also. Every oscillatory motion is periodic, but every periodic motion need not to be oscillatory, okay. We can say oscillatory motion be periodic because at regular intervals the motion is being repeated, okay, but every periodic motion is not oscillatory, okay. Example is circular motion. Circular motion is a periodic motion. At regular intervals the motion is being repeated, but it's not oscillatory motion, okay, to and fro it moves. It's not an oscillatory motion, but it is periodic motion. So this statement is very important. So let's move on to next one. This statement is very important, and in previous year questions of JEE mains, this statement based question is asked, and assertion reason based questions also will be there on this question at the end of this video. In previous Neet they haven't asked this question, but in AIPMT before 2016 at one time the question is being asked, have been asked, yeah. So differences between oscillation and vibration. So you may get doubt your oscillation and vibration are same, because oscillation is producing sound, oscillation is producing waves, vibration also producing some waves or deflections. But why those are different? So the main difference comes at frequency. So here frequency is less in the case of oscillation. For example, branching of your tree. So let me show you. See, back side there are some trees, okay, they are being oscillated, okay, they are being oscillated, they're moving from to, their frequency is less, because for example, let me consider this pen as branch of tree. Okay, it is coming slow, so this is at mean position. Okay, it is straight, it is being in the position of straight position to my face. It is moving up and it is moving down, to and fro it is moving slowly, means per 1 second. When it moves high, it produces more waves. I mean, let me just say this wave is going up and down, up and down. I mean, positive displacement and negative displacement is being shown. So here, oscillation, when we say that wave as oscillation, here when the frequency is less, I mean, per 1 second, the number of waves processing is very less, means it is moving slowly. Per 1 second, the waves show maybe 2 wave or 3 wave, but in vibration, it is moving continuously. Okay, for example, when your mobile is in vibration mode, okay, it vibrates. The mobile is being disturbed, it vibrates, it produces some vibrational waves. So those are very very fast. I mean, per 1 second, 10 to 15 or 15 to 20 waves are being passed per 1 second of time. So then frequency is high for vibration. For example, in strings of musical instruments, I already told you guitar, sitar, violin are the examples of musical instruments in which strings are being produced some waves. Okay, it produces some motion, okay, periodic motion. So let's move on to next slide. So the collective, sorry, here I did mistake. It is not collectis, it is collective. It's my mistake, sorry for that. The collective oscillations of the constituents of a medium manifest themselves of waves. So collective oscillations means group of oscillations of constitutions of a medium. Okay, for example, when you take a tuning fork, you hit it and container or beaker containing water with the tuning fork. It makes some disturbance in the container or beaker. So okay, so then the water gets disturbed. So what is water here? Water is a medium. Okay, water is a medium. The water particles are being disturbed and produces waves. So okay, they manifest themselves, they produce themselves, I mean, they consider themselves as waves. Okay, so examples, what are the examples of waves? Examples are water waves. Just now I discussed about tuning fork and that beaker containing water example. Okay, second one is seismic waves. So you are listening these waves newly, I think so. I think you know the movement of tectonic plates, which we have studied in 9th class and 10th class. Okay, geography. So seismic waves are the caused by sudden movement of earth. When tectonic plates suddenly move, it produces some waves which leads to earthquakes. Okay, those seismic waves are examples of waves, sudden movement, sudden disturbance such as in the tectonic plates of the earth. It may cause that earthquakes. Okay, last one is electromagnetic waves. You already know about electromagnetic waves because of electromagnetic waves you are listening my lesson. Okay, I think you understood. Because of transmission of these electric signals, okay, transmission of data from server to your laptop or mobile, or from my laptop or mobile to YouTube server, and so because of all these electromagnetic waves, the transmission is being done. Electromagnetic waves is also example of waves which is a mixture of electric wave as well as magnetic wave. So let us see the explanation in NCERT. Okay, NCERT. Very often the body undergoing periodic motion has an equilibrium position somewhere inside its path, means in its path it will be having an equilibrium position. When the body is at this position, no external force acts, means it is at rest. Therefore if it is left at that rest, it remains there forever. So if it is rest at rest, automatically it will be at rest only. So let's move on to next topic, about the relation between oscillatory motion and periodic motion. I have already explained in the last slide. Please highlight the point: every oscillatory motion is periodic, but every periodic motion need not to be oscillatory, and the circular motion example is very very important. Next point: simple harmonic motion is the simplest form of oscillatory motion. Please highlight that point. So video will become lengthy. if we study all the lines. So we will be going with subtopics. Subtopic 1, period and frequency. The smallest interval of the time after which the motion is repeated is called its period. So I have already explained you about periodic motion. In periodic motion, the motion is being repeated at regular intervals of time, and that time period is denoted with t. So the time period is called period of periodic motion. Units of period is second inverse, but for too slow or too fast periodic motion, another units are also used. According to NCERT, examples for other units are for quartz crystal, microseconds. Second example is very important. Orbital period of planet Mercury is 33 days. Third example, Halley's Comet. Halley's Comet is a large object made of dust and ice that revolves around the sun. It appears after every 76 years. That was in previous year question, PYQ. After how many years Halley's Comet appears? So remember second and third example. Next, frequency. Frequency of the periodic motion is denoted with nu, which is a Greek symbol. Reciprocal of time period t is nu. I already told that nu is frequency. So from that we get equation nu equal to 1 by t, or t is equal to 1 by nu, where SI units for these equations is second inverse. For frequency, SI unit is second inverse. But after Hendrik Rudolf H, unit name is given as H. For frequency, units are 1 H, and 1 H is equal to 1 oscillation per second, which is denoted with second inverse. Let us study period and frequency in NCERT. The smallest interval of time after which the motion is repeated is called its period. Highlight that point. And in next page, which are either too fast or too slow. I mean periodic motions which are either too fast or too slow on the scale of seconds. Other convenient units of time are also used. For example, quartz crystal. Second example is orbital period of planet Mercury, and third one is Halley's Comet. And reciprocal of t gives number of repetitions that occur per unit time. This quantity is called the frequency of the periodic motion. So I already told you that frequency is equal to 1 by t. The relation is given in the form of statement. Let's move on to next slide. Let us see an example problem 14.1. On an average, a human heart is found to beat 75 times in a minute. Calculate its frequency and period. That means required time period t and frequency nu. So let's take from the given data, time period is equal to 75 by 60, where 1 minute is equal to 60 seconds. Time period will be 1.25 seconds. And for frequency, we already know the relation that nu is equal to 1 by t, which will be equal to 1 by 1.25 equal to 0.8 Hz. So let's go to second subtopic, that is displacement. What is displacement? Change with time of any physical property under consideration is called displacement. When a physical property, for example physical body, changes with time, its position is changed, then it displaces. Thus it is called displacement. It is more convenient to measure displacement of a body from its equilibrium position. What is equilibrium position and why should we measure from equilibrium position? Because equilibrium position is the position at which the physical body is in equilibrium with the surface or base on which it is being situated. For example, from mean position, the body gets deviated, the body gets changed its position with respect to time, then it goes into motion, means it is changing from rest to motion. So the rest position is termed as here equilibrium position. We should measure displacement from equilibrium position because state of body is being changed when some external force is acted upon the body. So when we apply some external force to a body, then it gets displaced from its original position or mean position or equilibrium position. Thus we conclude that motion starts from the equilibrium position and displacement is also start from the equilibrium position itself. So here let me explain you with the diagrammatic representation. Let's see, this is body of M1, this is also M1. So this is at equilibrium position, but when external force F external is applied on it, then it will displace. Let's make this is in scale 1 2 3 4 5 6. So here what 7. So its displacement is denoted as final minus initial. This is an x-axis, so x final minus x initial is equal to is equal to 7. So what is the displacement here? 7 is displacement. So displacement is being started from the mean position itself. It is starting from mean position only. Next, displacement variable. So what is displacement variable? The angle from the oscillating body to its mean position about can be written as function of time, may be referred as displacement variable. Means a body is oscillating. Let me explain you. This is wall clock, this is simple pendulum, this is bob. So it is oscillating about an angle theta. Then its mean position O can be written as function of time, may be referred as displacement variable. So O can be written as function of time, okay, f of t, in terms of f of t. Thus we can say it as displacement variable. Displacement variables are not only meant for position, means they are not only for position change, they can also meant for voltage across a capacitor. For example, when we take a capacitor, voltage displaces, voltage changes. Voltage changing with time in AC current. So in alternating current, with respect to time, voltage also changes. Pressure variation in time in propagation of sound. So with respect to time, during propagation of sound, pressure variation, increase in pressure or decrease in pressure with respect to time can be denoted by an displacement variable. Change in electric and magnetic field in light wave, it is also an example of displacement variable. Displacement variable can be negative or positive. Please underline this point. It may be negative or positive. Displacement can be given by a math function, that is f of t, function of t is equal to a cos omega t, where omega is equal to angle from mean position. So for this function we can write a period function as f of t is equal to f into small t plus capital T. F into small t plus capital T. Remember this formula, I will be explaining about it in next further videos. French mathematician Joseph Fourier gave a statement about periodic function as any periodic function can be expressed as superpositions of sine and cosine functions of different time periods with coefficients. Okay, any periodic function can be expressed as f of t is equal to f into small t plus capital T. So this can be expressed as f of t is equal to a sin omega t. From this only this is derived, okay. So these will be not asked in Neet, but just remember. Let us see. If the given function is in the form of sine, sine after w, sine, it's not w, it's omega, sine omega or cos omega or sine omega plus cos omega, then they are considered as periodic functions. So the given, for example, they will be asking which of the following is non-periodic function. Means when you solve that equation, you will be when you simplify or expand that equation, you will be getting as sine omega or cos omega or both sine omega plus cos omega, then we can say it as periodic. But if you not get like that, then it is said to be non-periodic equation or non-periodic function. Let us study displacement in NCERT. We define displacement of a particle as the change in its position vector. In this chapter, we use the term displacement in a more general sense. It refers to change with time of any physical property under consideration. I have already explained about it. For example, in case of rectilinear motion of a steel ball on a surface, the distance from the starting point as a function of time is its position displacement. The choice of origin is a matter of convenience. Consider a block attached to a spring. The other end of the spring is fixed to a rigid wall. Generally, it is convenient to measure displacement of the body from its equilibrium position. For an oscillating simple pendulum, the angle from the vertical as a function of time may be regarded as a displacement variable. The term displacement is not always been referred to in the context of position only. There can be many other kinds of displacement variables, such as voltage across capacitor. We have already studied all these. The displacement can be represented by a mathematical function. I have already explained about it. F of t is equal to a cos omega t. There is nothing to explain here. Next, the value of the function remains the same. So after all this, we will be getting final equation as f of t is equal to f of small t plus capital T. Remember that equation, and remember the scientist name Jean-Baptiste Joseph Fourier. He gave the statement, any periodic function can be expressed as a superposition of sine and cosine functions of different time periods with suitable coefficients. So please highlight this statement. Already in NCERT it is being written in bold text. Now it's MCQs time. Let's solve some MCQs now. First one is, what is the orbital period of Mercury? This is direct MCQ from NCERT. So let me explain you the answer. 33 days. It is from direct line from NCERT. 33 days. And next, what will be the time period for a string of guitar whose vibrations are 55 per minute? So let's solve this question. 55 per minute per 1 minute. How many vibrations per 1 minute? 55. Now we have to find out time period. Okay, so 55 by 60, because 1 minute consists of 60 seconds. So it will be 0.91 actually time period in seconds, but option is not there. So actually they gave options for finding out frequency, I think so. If we do 1 by 0.91, around it gets, I'm doing 1.09 it will be first option. But they asked the question wrong. It's not time period. Okay, it should be frequency. It should be frequency. The question is wrong. For frequency, answer will be 1.09. Okay. Next, assertion recent type question. Orbital motion of a planet is periodic motion. Yes, the statement is true. Every periodic movement is oscillatory motion. It's wrong. We already studied that statement. All oscillatory motions can be considered as periodic motion, but all periodic motions are not oscillatory. So reason is false. Reason is false. Assertion is true. So option 3 will be correct answer. Next, the time period for an oscillation is given as 0.5 seconds. They give time period. Let's find out frequency. They asked it frequency. Frequency mu is equal to 1 by t is equal to 1 by 0.5. Answer will be 2. Option B is correct answer. Next, who gave the statement, any periodic function can be expressed as superpositions of sine and cosine functions of different time periods with coefficients? This is direct NCERT bit. Option C is right. Joseph Fourier, we have already studied about it. So MCQ is also completed. So please see description for online practice test, which is totally free, and result will be generated immediately after the submission of the test. Thank you for watching, and next classes on the remaining objectives will be uploaded as soon as possible. Thank you.